Hello, Algebra 1 students. Today we're going to start our first online lesson. Today's lesson, we're going to start talking about quadratic functions. This first one is just kind of an intro. We're just going to talk about different features of a quadratic function, what quadratic functions even look like. I would encourage you to take some notes as we go through this. Obviously, you don't have the handout that I usually give in class, so you're just going to have to make do with what you have. So just to start here, again, we're talking about quadratic functions today. If you remember from our polynomial unit, quadratics mean that it is something that is degree 2, meaning that when we see equations, we are going to see an x squared. Apologize for the poor writing here. It's a little bit hard to write on my computer. It's going to be an x squared somewhere in the equation that we're looking at. We will see here shortly that quadratics, and the reason why I have these pictures here, when we graph them, they're going to make some nice U shape. It might be flipped upside down. Here on the McDonald's bridge, there's another U shape. And sometimes it's even going to be, or sometimes it's going to be facing up as well. It's not always going to be shaped down. The cool thing about quadratic functions is there's so many things in life that are modeled by a quadratic path. I think a lot of sports, right? If you think about a volleyball, right, it comes down, then it goes back up, and then it comes down, right? That makes a quadratic, or it follows a quadratic path. So that's what we're going to explore in this unit. There's what you can say you can do by the end. We're going to get through some of this. Today's lesson is just going to be half of these notes, and then we'll have to finish the other half for the second lesson of this week. This is just something to look forward to. Eventually, we'll hopefully get to some word problems where we can see quadratics in action. But again, many things in life follow what we call a parabolic path or a quadratic path, right? If we think about somebody, if we see this kid over here kind of throwing the ball, right? He throws it up and then it comes down. Again, it makes that U shape, which is that quadratic, or which can be modeled by a quadratic function. So some key concepts. First off, standard form of a quadratic function. A quadratic function is a function of the form y equals ax squared plus bx plus c. And we've seen this form when we've been factoring, right? When we factored, we took a times c and we put that at the top of the x and we put b at the bottom. We've seen this form before. That's where a cannot be 0. And the reason why we say a cannot be 0 is because if a was 0, then it'd be 0 times x squared. Well, that means then the x squared is nothing, right? Because 0 times anything is 0. So then it would no longer be a quadratic function. It would actually be a linear function. So again, a cannot be 0. When we graph a quadratic function, it's going to make a nice U shape. It's going to look something like this, nice U shape. And we call that U shape a parabola. So you're going to hear me use that word quite a bit, and I think I've already used it a little bit in this video. But this over here, this is an example of what a quadratic function looks like. Again, that U shape we call a parabola. So some essential understanding here is a quadratic function is a type of a non-linear function, right? Linear means it's a line, so non-linear means it's not a line. That models certain situations where the rate of change is not constant. So for instance, if we looked over at this table here, we would see even before we graphed it, and we can use graphing to help, but if we look for the pattern with the y values, which we've done before, if you notice here from -3 to -1, we are adding 2. Same thing here, -1 to 1, we are adding 2. So if we check 1 to 3, we're adding 2, 3 to 5, we're adding 2, so that means the rate of change is constant, which would actually make this function, before we even graph, it makes it linear. The rate of change is constant. It's a linear function. Again, we can graph just to make sure. So if I just plot these points, 0, -3, 1, -1, 2, 1, 3, 3, and 4, 5. Right, we see we have a nice linear function. Right, it's a line. But up here we said that quadratics are a type of nonlinear function, meaning they're not a line. And we see that if we look over here at the y values, and if we look, how do we get from 7 to 4? Well, it looks like we subtract 3. How do we get from 4 to 3? Well, we subtract 1. 3 to 4 looks like we add 1. Right? Clearly, that rate of change is not constant, which means it's not linear. So that gives us a good hint that it might be a quadratic function because a quadratic function is a type of nonlinear function. So if we just go ahead and again plot these points, so negative 2, 7, 1, 2, 3, 4, 5, 6, 7. I got negative 1, 4, 1, 2, 3, 4, 0, 3. I got 1, 4, and I got 2, 7. So again, if I graph this, and again, bear with me, it's a little bit harder to do with my fingers here, but it looks like I get a nice U shape, clearly not linear. It's a nice parabola, so it tells me it's a quadratic function. Notice, just like when we were graphing lines, we must put arrows on each end because we are just graphing a part of this quadratic function. We are not graphing the whole thing. So the arrows indicate that it keeps on going. Again, quadratic functions are nonlinear functions because the rate of change, again, looking at the table, is not constant. All right, so moving on. Again, a quadratic function is an equation in this form, ax squared plus bx plus c. Again, a big idea with this is that a cannot be 0. Every quadratic function has a U-shaped graph called a parabola, and that's something we've talked about already. One word that's going to be new to us, or a new vocab word on this side, is the idea of the vertex. The vertex is either the lowest point on the graph or it could be the highest point on the graph. Basically, what I think about it as, the vertex is like the tip of the parabola, right? The tip right here, where the two sides come and meet. So here we'd say the vertex is the point 0, 0, where the two sides of our parabola meet. And here it'd be the lowest point on our graph, right? Every other point is above it. Whereas if we look over here, the vertex, again, where the two sides come and meet, would be right here. Since this parabola is flipped, right, upside down, now this vertex is actually the highest point on the graph. Again, the vertex here is the point 0, 4. 0, 4. Since, if we just go back to this example over here, since the vertex is the lowest point on the graph, we say that the vertex is a minimum, I'm just going to do min for short, value. Over here, since the vertex is the highest point on the graph, right, there's no points on that graph that are higher than the vertex since it's flipped upside down. Here we'd say the vertex is a max. And sometimes I'll ask you, is the vertex a min or a max? Here it's the highest point, so it's a max. Here it's the lowest point, so it is a min. So sometimes we might say, well, how do we know if we're just looking at an equation if a vertex is going to be a min or a max? And we can actually tell that from our a value. So the rule is, or what it says right here, it says if a is bigger than 0, so my leading coefficient from the x squared, that is bigger than 0, then my parabola is going to open up, meaning it's just going to make my normal U shape. It's going to look something like that. Whereas if a is less than 0, then the parabola is going to open down, meaning it's going to be flipped. And this is a similar idea to something that we've seen before, right? When we were talking about absolute value functions. If you remember that from a while ago, right? When we graphed absolute value functions, they made a nice V shape. And we saw when we transformed it, when we moved it left, right, up and down, things like that. If there was a negative out front, it actually made it flip. Same is true here. If a is positive, it's going to open up, it's going to make a normal U. If there's a negative out front, so it's a negative a value, then it's going to be flipped. This next slide just again explains that further. Again, if a is bigger than 0, if a is positive, it's going to open up. If it opens up, then that means that my vertex is the minimum point. It's the smallest point on my graph, which would make sense. Again, if a is less than 0, then the parabola is going to open downward or it's going to be flipped is what I often say, which means the vertex then is the maximum point. One other kind of set of vocab that we have to recall before we do a few quick examples here is something called the axis of symmetry. The axis of symmetry of a parabola is a vertical line passing through the vertex. Or in other words, I think about it as the line that when I draw it, if I kind of just trace over this line over here, if I were to draw the axis of symmetry, that means if I take my parabola and I fold it over that axis of symmetry, the two sides are going to line up. It's the line that cuts right through the middle. Again, it's the vertical line passing through the vertex. It divides the parabola into two symmetric parts. Since it's a vertical line, if we think back to first semester on our linear, when we did graphing lines, our linear function section, we know if it's a vertical line, it's always going to be x equal to some number. That's how vertical lines work. It's always x equal to some number. So in this case, the axis of symmetry should be x equal to, and hopefully you notice this, I have a little mistake on here, maybe did. The vertex or the axis of symmetry should not be x equals 3, but it should be x equals -3, right? Because it goes through x value of -3. And it's just the line that cuts the parabola in half. It's always going to be x equal to because it is a vertical line. So thus far we have some vocab words that we have to understand, right? We're talking about quadratic functions. We've talked about when we graph a quadratic function, it's going to make a nice parabola shape or a nice U shape. We talked about the vertex of the parabola. It's where the two sides of the parabola meet. Sometimes that vertex is a maximum value. In this case, on this example, it's a minimum value. Since it's a minimum, we know our a value must be positive because it opens the normal way, a nice U shape. We know if a is less than 0, that leading coefficient, then it's going to be flipped. And then we have this idea of the axis of symmetry, which is the line that just cuts straight through the middle of the parabola. So here's the next slide. It says describe whether the parabola opens up or down. So again, to determine this, you just look at the a value, and the a value should tell you if it's going to open up or down, which then tells you if your vertex is a max or a min. I would encourage you maybe to pause the video and try these quick by yourself first, and then turn it back on and we can walk through them together. All right, hopefully you had a chance to try these. We'll go over the answers now. So again, to determine if it opens up or down, you just look at the coefficient up front. Since a is negative, that means that it's going to be a flipped parabola. It's going to be a parabola that's opening down. So that means, again, we're going to say it opens down. And I know it doesn't ask this, but if they ask us about the vertex, we would say that the vertex, in this case, would be like right there. That tells me the vertex is a maximum value. Vertex is a max. It's the highest point on our graph. Whereas if we look at this one over here, again, we look at that leading coefficient. It is positive. So that means if I were to graph it, it would make that normal U shape. So that means looking at that graph, it should be opening up. Again, if I talk about the vertex, in this case, the vertex would be somewhere down here. So that means the vertex would then be a minimum value. It's the smallest point on our graph. Looking at this next one, again, a is positive. So again, it's still going to be opening up. It's not going to be flipped. Again, if I talk about the vertex is still going to be a minimum value. And finally, this last one, don't let the fraction throw you off. We don't care if it's a fraction or not. We just care if it's positive or negative. And it's still positive, so it's still going to be opening up, just like we've seen on the last two examples we just did. And again, the vertex is still going to be a minimum value. So that's the first video for today. Unfortunately, I couldn't get quite through all the notes on just one video. So once you finish this one, you'll have to open up the second one to finish for today's lesson.